Bhavya, your mic is off. Right.
Good evening.
Okay. So last time, any doubts in that one?
No, sir.
Yes, sir.
You checked your notes last time notes.
Yes, sir.
Okay. Right. There was one silly mistake here. Sign and cos interchanged. And this homework problem, you did this one,
Yes, sir.
Bhavya?
Yes, sir.
Okay. All right. So let us assume the answer is correct. What about this one,
Yes, sir.
Bhavya?
Yes, sir.
Okay. So we move to today's class. According to Newton's second law, what is force?
Mass into acceleration.
Okay. There is something much more basic than that. What is it? Rate of change of
Momentum.
dp by dt. So I can define another quantity, which is dp, which is force into time dt. Okay. So this quantity I call as impulse. Okay. So impulse is change in momentum. Right. So we define this new quantity called impulse, which is change in momentum, which is force into the time duration. Bhavya, is it clear?
Yes, sir.
We are defining a new quantity impulse. Okay. Due to the third law of motion, which states that to every action there is an equal and opposite reaction. All right. If there are two bodies, A and B, a body A and body B, if the force felt by body A is FAB, then there will be another force felt by the body B due to A. Okay. These two forces are equal in magnitude and opposite in direction. Right. So can you give an example of this sort of a force? Bhavya,
Yes, sir.
can you give an example of this sort of force where you have two bodies A and B? The force experienced by A is A due to B, and force on B is FB due to A. Example, Sun Earth system, right?
Yeah.
Sun is pulling the Earth and Earth is pulling the Sun, and those two forces are equal and the directions are opposite. Another thing is if you have a mass placed on a rigid surface, say Earth, what are the pair of forces here?
Gravity and normal.
Yeah. So basically the normal reaction will be felt by the mass. Okay. And there will be another normal reaction felt by the Earth. Okay. This normal reaction felt by the mass is the force which the Earth is applying on the mass, and the normal reaction felt by the Earth is the force which the mass is putting on the Earth. Okay. These are action reaction pairs. Okay. Next is conservation of momentum. It's related to the Newton's second law. So it says that the momentum of a system initial is same as the momentum of the system final. If there is no external force acting on system. Okay. So this statement I think we'll understand when we take some examples. So system means it should be isolated from the rest of the universe. Okay, that's what is written in another way. Total amount of an isolated system is conserved. Isolated in the sense there is no force acting on the system. If there is some force acting on the system, then it's not isolated. It's in contact with some external things. Okay. This same of putting in another way that if there is no external force acting on the system, then the momentum of the system is conserved. Right. Okay. Let's try to solve this example. You have pen and paper, no? Let's try this one. First, paraphrase the problem. My paraphrasing is clear. Bullet of mass 0.04 kg, 90 meters per second. It is the wooden block. This is the wooden block. Okay. It enters at this point and it travels this much distance. That distance is 60 centimeters. Okay. So we have to find the resistive force exerted by the block on the bullet. The block is stopping the bullet, right? So it's exerting some force on it. So getting the idea how to do it. Bhavya?
No.
What about Daksh?
Sir, do we need the time for this?
No. Why do you need the time? The time you can calculate. Time you can calculate if you want. See, what is the speed with which the bullet hits this entering part?
90 meters per second.
Bhavya, don't scribble. Concentrate on the problem. Bhavya, what is the velocity with which they are entering the block? U, right? Okay, let's call it U. And what is the value of U?
90 meters per second.
Concentrate on the problem, not anything else. Is it clear? U is 90 meters per second.
Yeah.
Okay. What is the velocity here? V.
0.
Okay. Right. And the distance is given, right? 60 centimeters.
Yeah.
Okay. So from this, what can you find?
Time.
Time is not necessary. See, resistive force is what? Mass into acceleration, right? It's actually deceleration because it's resisting. So mass is known. So if you find the acceleration, then you can get this resistive force. So from V, U and distance, find A. You have to find the acceleration. There are three equations of motion, right? V equal to U plus AT. Second one is AC equal to UT plus half AT square. What is the third one?
V square is equal to U square.
So which one you'll use for this one?
Third.
Yeah. From that find acceleration. v square equal to u square plus,
Sir, is this question of this chapter only?
yes, because this is coming, no, if equal to ma,
Okay.
v is 0, u square is 90 square plus 2a. What do we calculate the unit? 90 is in SI unit. This is 60 centimeters, so it is 0.6 meters. So it is 90 square, 8100 divided by 0.6. So this is the acceleration. From this resistive forces, no. Don't calculate the numbers, it's not important. Just get the steps. Got the thing, no? Acceleration negative because it's stopping the reducing the velocity, and resistive force because it is reducing the velocity. So the sign is clear. So the steps are clear.
Yes, sir.
Okay, we'll move to the next one. Okay, this one, the motion of a particle, mass m is described by this one. Find force acting on the particle.
Gravity.
As he said,
Oh wait, never mind. No, we're supposed. I'm fine. Okay, never mind. Yeah.
Bhavya, how do you do it?
That is the second law of motion given, right?
Yeah.
So that is velocity.
Okay, how do you find force?
Ma.
Yeah, so m is known. Okay,
Yeah.
he has given us m. So m is known.
Yeah.
What about acceleration?
9.8 meter per second.
Yeah, 9.8.
No,
Because it is g, right?
no, but you should not take it for granted. Acceleration is d square y by dt square. It's actually dv by dt. No, acceleration is this is 1D problem. dv by dt, and velocity is dy by dt. Daksh, this is 1D problem
Okay, so
because only y is involved. There is no x and z. Okay, so this is equal to d square y by dt square. So you have to differentiate this one. First, dy by dt is what? U plus 2gt. Is that right? Derivative of t is 1. Derivative of t square is 2t. So this 2 will cancel. It is just gt. Is that right? And then differentiate again. D square by dt square is equal to g. So acceleration is g. From that, force is m into g, which is basically what?
8.
Yes. That is the only force when a thing is dropping freely on Earth's surface. The only force acting on it is its weight, right? If that is the only force, this is the equation of motion is y equal to ut plus half gt square. Okay, you have to differentiate this twice and then come to the conclusion that acceleration is g. Not before that. Daksh, is it clear? Daksh?
yes, sir.
Okay. Next one. First, paraphrase the problem, draw a figure. Bhavya done?
Yes, sir.
Impulse is change in momentum.
Formula for impulse, can you please repeat?
Change in momentum,
Okay.
just delta P.
Okay.
So isn't change in momentum is also acceleration, right?
No, rate of change of momentum.
Force.
Oh, that's rate of change in momentum.
Delta P by delta T. Right now we just
So
have to
change in momentum is change in velocity.
no mass into velocity.
So, but never mind.
This 1D problem or 2D problem? Bhavya?
1D.
Okay. Okay, let me take this direction as positive. Okay. So what is initial momentum? M into V, right?
Negative 12 into
No,
0.15.
I've taken this as positive direction.
Yes, sir, I'm saying negative.
Why negative?
Sir, because it's going to be negative direction, right?
No, I have defined my positive direction like this, no? And initial velocity in the same direction.
Sir, but
See, I have defined like this. You can define the other way also. Why do you want to define like that? That's not necessary.
okay.
Okay.
Oh, you've defined, okay.
You define one way and then stay consistent with that and then not change it. Okay, so initial velocity is m into 12. Okay, what is final momentum?
Minus M12.
M into minus 12. Okay, so delta P is what? Final minus initial. That is minus 24 m. Daksh, is it clear?
Yes, sir.
Okay, so first step is paraphrasing. Don't skip this step. Okay, after that you have to solve the problem. Shall we move to the next one?
Okay, sir.
Bhavya,
Yes, sir. Yes, sir.
okay, this one. So in the first case, it's going and hitting straight, right, at 90 degrees, and is coming back. So what is the force exerted on this wall by the ball? It is uh, rate of change of momentum. Okay, he's just asking the direction of force. Okay, so final momentum and initial momentum. Suppose I take this direction as positive. Okay, so the final momentum is what? M into U minus, right?
Yes, sir.
And initial is M into V, M into U, right? So delta P is final minus initial minus 2m into U. Okay, this is force experienced by the ball.
Yes.
This is force experienced by the ball. Okay, that is in the negative direction. The force on ball is this way. So the force on the wall will be the other way. This is by Newton's third law. Bhavya, got it?
Yeah.
We have considered the initial moment of the ball and the final moment of the ball. So delta P is off the ball. So everything is off the ball. So it is the force experienced by the ball. Okay. And the force experienced by the ball will be opposite to that of ball by Newton's third law of motion. Okay. And here there is the force is actually delta P by delta T, no? From time. It is minus 2 mu by delta T. What is the delta T? Any idea? What is the delta T?
Sir.
Huh?
No, sir.
Okay. See, this thing goes and hits it. Okay. And it will take some time to rebound. It will be a very, very small time. Okay. That rebounding time is delta T. If you want to see exactly what is happening, this wall will be like this. Okay. The ball will come and hit it. What will happen is the ball will deform. Okay. It will go and then it will come out like this, the wall. And then it will come out like so. There is some time in which the wall goes and hits it, and then it comes back. Okay, that you can say interaction time. That time is delta T. It will be very, very small, maybe 10 raised to minus 3 seconds, something like that. Some small value, but the direction is force on the wall is towards right. Okay.
Okay.
Daksh, is it clear?
Yes, sir.
Okay. Move to the second case B. Okay, the first A, is it 1D problem or 2D problem?
1D,
Second case B,
2D.
because X and Y are there. U has got two components. And even if you take the motion of the ball from say from this point to this point, X is changing and Y is changing, right?
Yeah, sure.
X is this one to this one, and Y is from this one to this one. So X is changing and Y is changing. So both are changing, so it's 2D problem. Now, what is the initial momentum? He has already given the axis, so we have to take this one. It's m into, is the momentum is a vector. Okay.
U.
U vector, no. Can you split it
Yes,
into
sir.
components? Let me call it UI.
Yeah.
Mu cos 30 I cap is mu sin 30 J cap. Is that correct? This U have to split into two components. One is like this, one is like this. So this direction and this direction. Any vector can be split into two components, right?
Yeah.
So cos theta is along the x-axis and sin theta will be along the y-axis. Is it correct?
Yes, sir.
There is a mistake, small mistake. Minus.
It will be negative.
Initial velocity along the y direction is it's along the -1. Okay. And what about final?
Final is
Cos 30 I cap is mu sin 30 j cap. What about the signs? I component, is it plus or minus?
I component is minus.
Okay. J component?
J is also minus.
No.
Totally plus.
Yeah, it is plus. Fine. Now delta P, this was the B case. Delta P is P final. That is plus I cap. So it will be 2 times mu cos 30 I cap, and then J cap will be, sorry, minus, right? Final minus initial, so it's minus 2 mu. And then final is mu, okay, plus 2 mu sin 30 J cap. Okay, so it is like minus I cap something, and then plus J cap something. So this is the force on the ball. Okay, so this is 2m cos 30 and 2m sin 30. Okay. So this is basically the resultant will be 2 mu at an angle. Okay, the force experienced in the first case is minus 2 mu. Here it is again 2 mu only, but the direction is different. Delta P is same in both the cases. Is 2 mu.
Problem.
Yeah, right. Initial momentum is correct, no? This is y component. I'm making a mistake in the first case. Right, here also in the final one, the momentum is negative, no? Y component.
Yeah.
Okay, Zoom, I have to shut down and log in again after some time, not now. Okay, so this is again minus. So the y component will not be there. This won't be there. Okay, so change moment just in the x direction, but this time the impulse is less. When it hits directly, the change in momentum is 2 mu. Here in this case, it's 2 mu cos theta, cos 30. Right? So the ratio of momentum is cos 30, which is root 3 by 2. Is it clear?
Yes.
There was a mistake here. So in the y direction, there is no change in momentum, only the x direction is changing momentum. And the force, so force held by the wall in the second case is less. So direct head-on collision will create more force. When it is hitting at an angle, one component is going to go unchanged. Only the x component will contribute to the change in force felt by the ball. The x component is a cause of the total initial momentum. Okay, so the impulse felt in the second case is less. Right. Okay, two blocks M and M are suspended. Okay, so they are in equilibrium. Equilibrium means they are at rest. Okay, so you have to find the ratio of M and M. Which block is mass M, A or B? Small m.
A.
A is small m and the B is capital M. Okay, so what should be the relation between M and M? So that thing is at rest. How do you proceed this problem? Bhavya?
Yes, sir. I'm thinking.
Free body diagram.
Yeah, I'm drawing.
Yeah, draw the free body diagram of A and B and then solve it. The tension in the string, if it is T here, what will be the tension here? Tension here. It's the same string, so it is the same T. Okay, just assume this result. You will understand why it is so later. The tension is a string is the same string, so the tension is same throughout. Tension here is T, here also is T. So if you try to draw the free body diagram of A, mg, and this force is T. Okay. Similarly, if you draw free body diagram of B, what is the force upward of B? Upward to B? Daksh,
Yes, sir.
what is this force? A, the upward force is T, right? Tension. For B, what is the upward force?
T.
Okay, if you draw the free body diagram of this pulley, okay, there will be force like this. 1T, another T here, and this
2T, 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 2T.
this will be pulling with another force. Let's call it T1. Okay, so T1 equal to 2T from here, and this is T1, which is equal to 2T. Bhavya, even a rod can transmit tension. String can transmit tension. Rod can transmit both tension and compression. This is like a rod, this connection.
Yeah,
Okay, so that rod can transmit tension. So this is the tension in that rod, T1.
it is tension, right? Tension.
Yeah. See, rod you can either pull or push. Okay, but while pulling, the rod will not extend much. Even same thing is true for string. But while pushing, the string will slack, but the rod will not slack.
So the answer is 2 lowercase m.
Yeah, one should be double of the other.
So the answer is 2 lowercase m.
From this you get T equal to mg. So 2m equal to m. So the big mass, capital M, is twice of the small mass. Usually the
So 2
small
lowercase m.
usually the small mass is denoted by a symbol, small letter, and big mass represented by the capital letter. So it is consistent with that. So this is the answer. Bhavya, clear?
Yes, sir.
Okay, this is the important step. Okay, as you go ahead, you can, without drawing this, you can straight away write here as 2T. Another way of looking at it is, you can consider pulley and block B as one system, one full system. This block B and the pulley I can consider as one system. Okay, so the force acting on the system is 2T, TT up here, and the down is M into G. Okay, the pulley is massless. Okay, so if you consider the pulley and the block B as a system, then the force acting upwards is 2T and the downwards is mg. So this is also another way of doing it. Clear?
Yes, sir.
Free body diagram you can draw for an individual body. You can also draw for a collection of bodies. Okay, so you can consider the pulley and the block B as a system, and the force acting on the system in the upward direction of 2T's, and in the downward direction is the mass of the block because the pulley is massless. Daksh, is it clear?
Yes, sir.
Okay. Okay, now the meeting will get cut. So you'll get a new ID. You have to use a new ID. Okay, let's continue until before it cuts. Same thing, try this one. Smooth slope, so no friction. Okay, free body diagram of the box. This is the box. Tension in the thread. Okay, and then if the thread is replaced by a spring of force constant K, extension in the string, extension in the spring. So what do you do now, Bhavya? Only two forces, no? Normal reaction is there.
Yeah.
Three forces. Now what do you do? How do you solve this problem? Daksh,
Yes, sir.
how do you solve this problem? You have to write the equations, no?
Yes, sir. I'm doing it right now.
So the force in which direction, which two directions I have to take?
You have to take the tension of the spring and the downwards mg sin theta and mg cos theta.
Okay. So, Bhavya, which should be the direction of x-axis?
Sir, the ground.
Parallel to the plane.
Yeah.
That will be convenient because if you take this as x and y, then there is only one force have to split into components because t is along x-axis and n is along y-axis. So only one force have to split into components. If you take the other way, uh, mg will be along y-axis and n and t both have to split into components. So this will be easier. Okay. So now, what is this angle? This angle. Or if I take the vertical, what is this angle?